Let's solve some homework exercises from section 2.5. Let's begin with homework exercise number 1. Use the given Venn diagram which shows the number of elements in regions 1 through 4 to answer the following question. How many elements belong to set A? Okay, so set A, you can see, goes right around here. So we're going to include, now everything's separated when we have the cardinality or the number of elements in each region. So region 1 and region 2, region 1 has 20 elements, region 2 has 24. Region 1 is the region with the elements in A that are not in B. Region 24 is the elements in A and B. Now again, these 24, even though they belong to B, they still belong to A, so you add them up. So it would be the 20 plus 24, which of course would be 44 elements belong to set A. Okay? All right, use the given Venn diagram which shows the number of elements in regions 1 through 4. How many elements belong to set A but not set B? So specifically, they are in set A, but they're not in set B. So these 16 that are in A are not in, but are not in B. So these are in B, so we can't include those, right? So it's only the ones in A, not in B, which would be simply the region number 1, which has 22 elements, cardinality of 22. So the answer would be 22, because we can't include the 16 because they are also in set B. We only want the elements that are in A but not B. Homework exercise number 3, how many elements belong to set A or set B? Now this is, when they say A or B, they mean in A or B or in both. So or means you always include the ones in both. So in A is 27. In both is 22. You do include those too. Whenever there's an or, you think of, you add the ones, you include the ones in both, and then these 10 are only in B. So it would be the 27, 22, and 10, which when we add them up, we get a total of 59 elements. So the or includes the number of elements that are in both A and B. That's the way we'll always interpret an or when doing sets. All right, how many elements belong to set A and set B? And means they gotta be in both A and B. So you can see here, region 2 is the only elements that are in both A and B, right? Because these 9 are only in A, these 21 are only in B. So the ones that are in both, the intersection where the two sets overlap, and that region has 24 elements. So that would be the correct answer, how many for in A and B. Okay, in this case, we want the elements to that, how many elements belong to neither set nor B. So nothing in A, nothing in B. So anything that's in the interior of either one, cross out. But notice on the exterior of A and B, we've got this 24 in region 4. So they are part of the universal, but they're not in A nor they are in B. So the correct answer is the 24. So it'd be the number out in region number 4, the region that's not in either of the sets A or B. In this case, it has 24 elements. Okay, now we're going to do, now we have the cardinality of each region. So that's, again, same way we've been doing the earlier problems. That's how many elements are in each region. Okay, now obviously we have 3 sets. How many elements belong to set B? Set B is right here. You can have elements that are in A, that are in B, that are in all 3. Okay, so anything in B is right here. You can see there's a 7, a 9, a 2, and a 1. 7, 9, 2, and 1. Those cardinalities of those regions all are in B. So when we add those together, 16, 18, and 1 is 19. So there are 19 elements that belong to set B, okay? You can include the ones, you must include the ones that are in A and B, all A and C, or all three. Okay, again, three sets, 8 different regions. How many elements belong to A but not C? Okay, so A is right here, correct? 3, 8, 5, 6, but not C. It can't be in C. Notice the 5 and 6 are also part of C, so we're going to get rid of those. So the ones that are left in A but not C would be the 3 and the 8. 3 plus 8, obviously, we can do that computation in our head, and we get 11, okay? So the 3 and the 8 are in A but not C. We had to get rid of the other ones that are in A because they were in C. We just wanted what's in A, only in A, it's in A but definitely not in C, the 3 and the 8. All right, homework exercise number 8. How many elements belong to set A or set C? Could either be in A, anything in A, or C, or it can be in both. And you include anything that can with B, as long as it's in A or C. So A is right here, right? 2, 8, 6, and 4. C is right here, 6, 4, 5, and 1. Now notice, though, you only add the numbers once. So we've got the 2, the 8, the 6, and the 4, and the 1, and the 5. The 6 and the 4 are both in A and C, but you only count them once, right? All right, so when we add those together, 10, 16, 20, 21, 26 elements, all right? The 2, the 8, 6, 4, 1, and 5, right? It's either in A or C. Add those numbers up, and we get a total of 26. All right, how many elements in this card? We got cardinalities, set A and set C. They've got to belong to both. So set A is here, okay? Set C is here. Okay, A, be careful, it doesn't include those 8 there. What are the ones that are in both A and C? In both the red and the blue, it would be what? The 9 and the 4, right? Intersection of A and C, 9 and the 4. 9 plus 4 equals 13. The 4's in set B, that's okay. It's also, as long as it's in set A and set C, it can be in B, that's okay. So we get a total of 13 elements. Okay. Homework exercise number 10. How many elements belong to set A, B and set C but not in A? Set B and set C got to be in both, right? So the overlap for B and C is 9 and 2, right? It's got to be in both A, B, and C, only the 9 and 2. But they cannot be in A, but we definitely don't want it in A. Notice the 9 is part of A, so we got to get rid of it because we don't want anything in not in A. So that leaves us simply with that region there with a cardinality of 2. So A and B, but not in A, so we got rid of that 9 in the middle, and we're only left with the region that has a 2 in it. All right, homework exercise number 11. How many elements belong to set B or C, but not A? So B or C. Okay, so we have what? Either B or C or both. So we have the 9, the 5, 8, 7, 3, 6, right? 9, 5, all those belong to B or C or both, but not A, right? So now again, A is right here, so anything in A we do not want, but not in A, so we're going to get rid of the 9, 7, and 8. They're part of A, so now what's left in B or C was what? The 5 and the 3 and the 6. Okay, the 5, the 3, and the 6. Okay, those would be the ones in B or C, but not in A. The 5, 3, or 6, add them up. 5 plus 3 is 8, plus 6 is 14, okay? The 5, 3, and 6, and that would give us a total of 14. All right, homework exercise number 12. Considering A, B, and C, how many elements belong to at least one of the sets? At least one. Anything inside any of these, it's going to belong to at least one, right? The 9 belongs to 1, 8's 2, 5's just 1, 2's in both A and C, 6 is in all 3, 1's in B and C, and 7's only in C. So you're just going to add up all these numbers except what? Not the 3, because that doesn't belong to any of them. So we've got 9 plus 8 plus 5 plus 2 plus 6 plus 1 plus 7. 9 plus 8 is 17 plus 5 is 22. 23 plus 22 plus 1 is 23. 6 more is 29. 2 more is 31. And 7 more is 38. Hopefully I did my arithmetic correctly. So when we add up those 7 numbers that are inside either A, B, or C, or a combination of more than one, we get a total of 38. Very good. Okay, we're going to stop this session here at exercise number 12. This is your math teacher, Dr. Swears. I hope you found this video helpful. If you have more questions on any of these problems, need more help, send me an email using the inbox in the Canvas course. Again, thank you for watching this video.